Hello grade 12s, welcome to my channel. Let us have a look at one of your nightmares when it comes to mathematics paper 2 in grade 11 as well as grade 12. This is Euclidean geometry. Now I have decided to take these sort of higher grade papers to show you how to work through some technical questions, to also show you some skills, some tricks, some techniques, and in fact to point out exactly where the other pieces fit into this puzzle. This is just to give you a bit of an understanding of how to handle higher order questions, so that if you get used to doing so, then it becomes easier to handle the common, easy, standard questions which you often have, and of course to also handle those one or two higher order questions in each section that you're going to come across. Now this is for the grade 11s who are crossing over to grade 12 next year, and those who will be willing to upgrade their mathematics in the coming year, whether in the May June exams or in the November exams. Either way, we're just going to work through this. So I've used some of the older papers because, truth be told guys, although you must not say this to your teachers, don't tell them, because some of them are involved in certain districts and provinces. Then they will start to know their secret is out. Most of the diagrams you will see in the previous exams have come from these older papers. But of course, they have been modified here and there, or at least different sets of questions have been asked, and sometimes similar sets of questions have been asked from a similar diagram. Now, in Euclidean geometry, of course, the most important is that we must give a reason for each statement we make. That's the main rule here. The rest is honestly history. Of course, it couples all the 3 steps in our summary from the previous video, and many other steps I kept talking about, the 3-step approach. Now let's look at this question 7. In the diagram below, the circle KLMN is drawn. Okay, we can see this is a cyclic quad because all the vertices are at circumference. Now we are told to use the diagram on the diagram sheet or to redraw the diagram in our answer book to prove the theorem which states that if O is the center of the circle, then angle L plus angle N are supplementary. Okay, so we need to prove that that sum is supplementary, or it adds up to 180. Of course, you guys are usually not used to diagrams being put like this. This is what makes this a higher grade question, because it's not the common diagram that is easy to see and easy to know what to do. But trust me, nothing changes, because all we do, we will spare these angles that we want to add. So our construction is to join OM and OK. So that is what we need to do. Of course, any construction must be in a broken line to show that it was not originally there. Okay, so that's what we do. And then of course we will create this angle O1 and angle O2. That's all we need to do. So we will start. Question 7. And then we have 7.1, and of course we are given circle KLMN with center O. Okay, now we are required to prove that the sum of angle L and angle N is supplementary. Okay, and of course our construction is we join OK and OM. Okay, easy. Then we get into the proof. Now we know for sure that essentially angle O2 is going to be equal to 2 times angle L, right? The reflex angle O2 is twice the angle OL. What is the reason here? Angle at center equals 2 times the angle at circumference. Okay. Likewise, we've got O1 is going to be, remember angle O1 is subtended by this chord or arc KM, and can you see the same arc subtends that angle at circumference, so it's going to be 2 times angle N. Again, same reason, angle at center equals 2 times angle at circumference of the circle. Now, we understand that, but angle O2 plus angle O1 gives us 360 degrees. Why is that? This is the revolution. Or one can say angles around a point. So this implies, now what is O2? It's 2 times angle L. What is O1? 2 times angle N. This gives us 360 degrees. Now what can we do? If we look at our 3-step approach, we've got a common factor here. So we take out the highest common factor by factorization. And then we divide by 2 throughout. So we will have angle L plus angle N is 360 divided by 2. Therefore, angle L plus angle N is indeed supplementary. Easy. So again, it helps again to challenge yourselves with some different forms of these diagrams rather than the usual. In case this gets thrown at you, you never know when it's going to come, and no one is going to give you a warning. So you might as well get used to knowing how to do this in a flash. Okay, good. So the construction statement is good. That statement and reason is good. That statement and reason is good. And essentially, this statement and reason is good, so 4 marks. Whenever we factorize, this is part of the 3-step approach. So this is already 5 marks. And indeed, getting to this one, even though it's given, we had to logically get to it. So this is how we would score those 6 marks. Let's move on to the next question. Okay, so remember, usually the property that we prove above is usually applicable in the next question. But it's not always the case, but we need to think about that. Now we're told in the diagram below, O is the center of circle ABCD. So there's our circle, and we can see this becomes a cyclic quad. And that's the center, okay? Great. Now we're told DC is produced. Once we hear that word produced, it means it forms a straight line. So we can produce that one. Okay, it's not doing the things you. Okay, must sort it out. Let's sort it out. So this simply says this forms the same straight line. Okay, great. So that's what we have. And can we see immediately once we hear that, we know that this angle is going to be equal to that angle. Why? This becomes an exterior angle of a cyclic quad. So try to see things immediately, guys. Don't wait until you know what, your brain is lost. Okay, to meet BODE, I mean, can you see this is the circle BODE? What do we notice? So we can see that this is yet another cyclic quad, BODE, okay, at point E. Okay, not a problem. And then we are told OE intersects BC at F. And then, of course, OE intersects BC. So this is already suggesting that this is going to give us vertically opposite angles. Okay, because when two lines intersect, vertically opposite angles are equal. All right, and of course we know F3 is going to be equal to this angle right here. Okay, we can look at something like that. Likewise, F2 is going to be equal to F4. So this is what we can appreciate. But now what more can we say? We will certainly appreciate that this angle right here is in the same segment as that angle B3, right? These are angles in the same segment subtended by chord OD in this shaded cyclic quad. Right, but what we will notice is that this side OB is equal to this side OD. Why? These are radii. Remember, we were told O is the center of the smaller circle. So those are the radii of the smaller circle. And so that angle B3 should be equal to that angle D2. These are angles opposite equal sides of this triangle OBD. So we can see that that triangle is essentially an isosceles triangle. Okay, good. So that's what we can say. Can we say more? Well, we know that angle D2 is itself equal to angle E2. These are also angles in the same segment subtended by chord OB in the shaded cyclic quad. So this already tells us that OE bisects this angle BED. So there can be a lot of questions constructed from this kind of thing. One can say prove that OE bisects BED. Can you see? Same diagram can be peddled for yet another bunch of questions. Not a problem. So that's about what we can say so far. Now we are told to let angle E1 be equal to x. It's already indicated, and so that is x, this is x, and that is x. Now we are told to determine angle A in terms of x. Okay, so how will we get there? We look at this. We already see that we've got x and x, and we want angle A. So this already tells you and I that we need to essentially use this. We essentially have to use this angle. We need to find that angle. As we can see that this angle is the angle at center subtended by chord BD in the smaller circle. that same chord subtends angle A at circumference. So this means we can use this relationship to get in here, then get this angle, then use the angle at center equals 2 times angle at circumference. Or alternatively, one can try to apply the theorem we just proved above. So we come here, we say that is equal to that, this is equal to that, then we can say this angle plus this entire angle should be supplementary. These are opposite angles of a cyclic quad. Then from there, we can use the angle at center equals 2 times angle at circumference. So however we want to do this, but again, to try and go back and then come back is ridiculous. I think once we get here, it's just easy to go directly into that angle and then move forward. So this is very easy when you see someone do it. But when you have to think about it, it becomes a lot harder. But can you see when you annotate the diagram, you try to piece it into its individual parts and you show how each part is related to others, it becomes easy to find a way of solving this question. Even though it may take you a while to figure it out, if you just read and then start getting this question, and now you have to wonder, where do you go? I will show you a very careless technique on solving these kinds of problems on my next video. But please refrain from that method. It is not good. It can work, but it is not good. But you need to have a bit of everything so that you can use whatever means feels necessary for a particular question. But this technique of always trying to interpret what is given on the diagram by annotating, it almost always works because it's bulletproof. Yes, there can be issues if you're not careful, but it mostly does most of the work. So this is how you maximize on your attempt. Anyway, we are going to start by saying angle B3. Should we say, maybe let's start. We know that the triangle that leads us home is this green triangle. We can start by saying in triangle BOD. We know that angle B3 is equal to angle E1, essentially equal to X. What is that? These are angles in the same segment. We appreciate that this is a cyclic quad. Okay, now we can say safely also, in fact, before I start this, it's always nicer, but anyway, let's not waste time. We can easily say also, we appreciate that angle D2 is equal to angle B3 and so equal to X. We can say these are angles opposite equal sides with radii. Okay, maybe let me be complete here. Let me be complete. Equal sides of a triangle with radii OB equaling OD. Now, one could easily have said OB is equal to OD and say these are radii, and then we can make this conclusion. That's not a problem. But at times, you can complex things as long as what you are saying makes sense, okay? It's good. Do not fall to the shorthand techniques of doing things. It's not the only way you can express your answer. As long as you provide a valid reason, that's what is important. Now, what are we going to say? We can say here safely, then I'm trying to see now. We can say then we know that angle DOB or BOD, maybe let's use this one like that. We can say angle BOD plus angle D2 plus angle B3 should give us 180 degrees. This is the sum of three angles of a triangle, right? Because our target is to find that angle. This implies BOD plus x is equal to 180 degrees. Therefore, BOD is going to be 180 degrees minus 2x. So that's what we needed. We can say, however, we understand that 2 times angle A is going to be equal to angle BOD. Why is that? We know that angle at center equals 2 times angle at circle. Okay, that's good. Now that we have said that this implies that 2 times angle A is equal to 180 degrees minus 2x, we divide by 2. This is going to give us angle A is 180 degrees minus 2x, all divided by 2. Therefore, angle A is equal to 180 divided by 2 is 90 degrees minus 2x divided by 2 is just x. And that's it. That's it. So, not a very difficult question, but one needs to know how to employ the systematic approach, okay? Very important. So, obviously, this statement is key. And this statement, mainly its reason, it's complex, okay? Very important. 2 marks. And then the 3rd mark comes here, right? The 4th mark is the statement. And this is the 6th mark over there. Now, we can give this portion here 2 marks. Why? Because the statement and its reason is quite key. That's how we score the 6 marks, guys, and we move on. As I said, don't just solve a problem and that's it. Solve it, enjoy the moment, then look back. How else could you have solved the same problem? As I said, we could go back, then use opposite angles of a cyclic quad and sort it out eventually. So that's good. Let's move on without wasting time. So we have 7.2.2. We've got A. We need to prove that BE is equal to EC. Can you see? We are trying to suggest that this triangle is an isosceles triangle. All right, okay. So how will we prove that? If we can prove that this angle C1 is equal to angle B, right? So if we can prove that, then this becomes an isosceles triangle, and that means those 2 opposite sides will be equal. That's how we're going to do it. But now, how do we plan our way through? Obviously, we need a particular triangle. We already know this angle is 90 degrees minus x, and we saw that it links up to this angle C1 as an exterior angle of this cyclic quad. So we already have x, we have this. So we can find F1, which is the exterior angle of this triangle. So basically, guys, we need to use this triangle as a means to an end to get into this purple triangle. And the purple triangle is going to give us B1. But we still need to justify that E2. That's not a problem. So we will be able to find E2. We'll be able to find F1. And that can help us to work out that angle B. So that's how, if we prove that that is 90 degrees minus X, then we know. Then we know we are good. All right. Okay. All right. Now let's start off. We need to link these two angles. We know that angle C1 is going to be equal to angle A, and therefore equal to 90 degrees minus X. This is the exterior angle of a cyclic quad. But of course we need to specify which one is this. This is ABCD. Okay, great. So our key is to at least identify angle C1. Now we want to work into that triangle. We can say in triangle BEF. What do we see there? Now, in this triangle, we need to justify two angles here. First, we want E2. Angle E2 is equal to angle D2 and so equal to X. Why? These are angles in the same segment. We saw that subtended by chord OB in the shaded cyclic quad. That's easy. Now we also know that essentially angle F1 is going to be the sum of angle C1 plus angle E1. This is the exterior angle of triangle. This time we're going to name it. This is E or C, EF. So we're using this as a means to an end. This is the stippled triangle. So this implies that angle F1 is going to be equal to, we just said this is 90 degrees minus X plus X. Therefore, angle F1 is essentially 90 degrees. Can you see? So this changes the characteristic here. It says, well, this is not just any angle, but it's a right angle. That's a right angle. And this also means this is a right angle too. Okay? Now, can you see? Another question can be constructed. If a line from center is perpendicular to the chord, it should be bisecting that chord. So another question can be constructed that prove that BF is equal to FC. Can you see? And you would be crying tears of pain and mayhem, because you'd be wondering, how am I going to come up with that? You see, this is why, guys, I want you to really sit on these, practice them without pressurizing yourselves. Use even your textbooks to get the theorems closer to you. Don't cram these. Try to work with these theorems without trying to remember them that much, so that it's easy. You don't carry this knowledge with fear and anxiety. Anxiety tends to suppress your memory, usually, because it only goes into survival mode for you. So when you are comfortable, you free your mind, therefore you can explore all your options. So try to approach it that way. Can you see? We've already created two questions that are not probably here. Have you noticed that? Yes, we did. Yes, we did. Now, let's leave that alone. But you can see there's so much we can say, guys. There's so much we can create. But let's leave it for now and just answer the question. Now, F1 is 90 degrees. We can simply say then, what do we want? We want B1. We can say then angle B1, B1 plus angle E2 plus angle F1 should be equal to 180 degrees. This is sum of three angles of a triangle. But now remember this triangle, this is the main one, BFE or BEF. Now our target is B1, so B1 plus, this is now X, right? No, yes, we did speak about E2. It's X plus 90 degrees equals 180 degrees. Therefore, angle B1 is going to be equal to, remember 180 minus 90 is 90 degrees, and then we transpose the X, it becomes negative. Can you see? C1 is equal to B1. We can say, therefore, angle B1 is equal to angle C1, and why is that? Each is equal to 90 degrees minus X. The only link is their size. We didn't have any other way we can say it. And if these two are equal, we can say, therefore, angle BE must be equal to EC. Okay, now we provide a reason again. These are the sides opposite equal angles in triangle. Now we're going to state it. This is BCE. Can you see, guys, we're moving from triangle to triangle to triangle, but in a very nice way, because all we have to do is to, just follow things nicely and essentially sort it out. Okay, just a moment, guys. Alright, guys, so this is how we sort out problems of this nature. And of course, this is a powerful statement to make up those 7 marks, and we can give that essentially, and we can give that and get that mark. So the first 4 marks comes from there. The 5th mark, remember, the three angles of a triangle, we normally don't get a mark for it, but we have to say it. But the result is what matters the most. So we've got 1, 2, 3, 4, 5. So linking these two, 6 and then 7. So this is how we score these 7 marks. Of course, certain questions have limited ways in which we can look at them, and certain ways have multiple ways we can look at them. So at times when the question is just like this, and you can see there's not really much we can say, this is the way to get to this, so we just stop there. We don't complicate our lives. At times what makes sense is just enough to work with. The last question says we need to prove that BE is not a tangent to the smaller circle. So obviously, guys, once we say not, it means we are just trying to say X is not equal to Y, literally. Because X was supposed to be equal to Y for this to be the case, to be a tangent. But then if it is not a tangent, then it means what satisfies this line being a tangent would not satisfy what would come from it. For example, the 10-chord theorem. So can you see, we know B1 is 90 degrees minus X, right? We already know that. But can you see this is the angle between what would be the presumed tangent and this chord, but this chord itself subtends this angle D1. Then it means we can prove that D1 is not equal to B1. But now looking at this structure right here, it doesn't look so easy to say we can find the size of, say, D1. It's not going to work. But now let's have a look a bit more. If we look at this angle right here, maybe let's choose a different color. Let's choose something different, maybe blue. So if you look at this angle, guys, but it's not coming out nicely. I don't like it. Maybe let's make it big and ridiculously big. So if we look at that angle, guys, this blue angle combines B1 and B2. For this to be a tangent, it should be equal to angle A. But can you see angle A is already equal to angle B1? So if we're adding something extra, this means this entire angle is not equal to A. And if that's the case, the tan chord theorem is defeated. Therefore, this may not be the tangent. So that's how I would look at it. Again, you look at many other possibilities, but this is just a 3-mark question. It doesn't need a lot. Although this question is not that easy to answer because you need to think about it. You see, questions that involve multiple steps and many marks are usually approachable. But questions that are like this, they are narrow in nature in how you approach them. And so it means you just need to understand that one little bit, then you've answered the question. If you do not understand that one little bit of information that is probably evident but you didn't notice, then you can't answer that question. But the good thing is that even if you don't answer it, you don't lose a lot of marks. All right, let's start. We can say here, technically, sometimes you just say, well, ideally, now let me see, what is the best way? Do we then assume this is a tangent first? I don't know. Maybe let's say assumption. Let's just say assume BE is a tangent. Okay? To circle ABCD. We make an assumption. Now, what are we going to say? We will say, we know that essentially angle B, okay, let's call this angle DBE, is going to be equal to angle B1 plus angle B2. We can say therefore DBE is going to be 90 degrees minus x plus B2. We will say, however, we know that angle A is 90 degrees minus x. Proved above. Okay? We can say, therefore, we can see that DBE is not equal to angle A. Because we can see clearly that we are adding something extra for DBE. Although this is common, but there's something extra. Or somebody may even put it this way and say DBE is greater than angle A. Because if we're adding something, this is already extra. So this is yet another option to show that. And then as a result, we can say therefore BE is not a tangent to circle ABCD. Sometimes you can say 10 chord theorem does not hold true in this setup. Okay? Or in this scenario. Maybe let's just be complete in this scenario. We are not talking about other scenarios, but this scenario, because we wanted to use the 10 chord theorem stories. And this is by far the most powerful, because we need to show what is our reasoning. Despite saying that, we can't assume the marker understands what is the significance of this angle not being equal to that. We need to provide a reason that if this was to be a tangent, we would have the 10 chord theorem holding. But now that it does not hold, it means therefore we can't be looking at a tangent. So this is great, guys. So what we can say, the most important here is essentially that statement, or optionally one can use that statement also. And essentially this statement here, I believe for me, it is going to be taking 2 marks at least, because it's quite a comprehensive thingy there. But one can even say, well, why 2 marks? I mean, it's just a reason. This was already given to us. We just needed a reason, so the mark is for the reason. We can then mark that to just highlight that fact, perhaps. But 3 marks in the bag. Okay? Good. Alternatively, how else would you do it? Just for fun now. Think about this angle. Think about this angle. Can you see the angle between the radius and what would be the tangent? Would have to be 90 degrees, right? Right. But now, the reality is it is not 90 degrees, because you will see that B1, let's just say, what is this angle? It's OBE. One stupid education that attacked our education system. I don't know why they adopted it, but they were trying to assassinate our education. Thank God it didn't really last long. Now we know that this is going to be B3 plus B2 plus B1, right? This is X plus B2 plus 90 degrees minus X. So these eliminate each other. So we can see that this becomes 90 degrees plus B2. Can you see it's not just 90 degrees? There's something extra. And so this means OBE is greater than 90 degrees. And therefore, this may not be the tangent, because the theorem that says the tangent is perpendicular to radius does not hold true. So you have to state that. So this is one other way to look at the same problem. So can you see there's 2 ways in which we can sort this out? So we are saying, is that 90 degrees? The answer is no, it's not 90 degrees. It came out to be greater than 90 degrees because to 90 we added some extra angle. So I hope, guys, you understand and you appreciate the complexity of certain questions and how small sometimes the thinking needs to be, as long as you understand what to do. Okay, now this is for a sum total of 22 marks, and I hope, guys, you've enjoyed the ride. Like I always say, don't move away from this question until you have looked at other possibilities. Try other means and fail. Please try and fail. For example, try to use D1 as a 10 chord and prove that D1 is not equal to B1. And find a way of expressing this somehow. You need to find a way. What is important is that, fact of the matter is that if you can find a way, then you can explain to us what is going on and look at other possible angles that may be looked for that are probably not so easily evident from the face value, but from connecting the dots, we start to see some equalities or implications so that you understand the diagram you just used. This will help you to explore other diagrams in the exams, and you will see that your ability to analyze and interpret, as well as logically place things where they belong, it will become second nature. You won't even need to waste time doing that. And that means every question is going to look like it's a joke, because you will be over-prepared. You can never say you're over-prepared though, because even if you can crack Euclidean geometry, you may find yourself getting stuck in trigonometry or analytical geometry or stats even. Statistics has a tendency to have some very naughty questions as well. Watch out. Of course, the bulk of stats is very easy to get the most marks, but there's always one or two questions that sometimes you wonder, what were these guys thinking? How would I think the same way too? Anyway, whatever guys, you should be ready, you should be doing your best and master your craft. Alright, so let's not waste time, let's move on to the next question. I hope you have enjoyed that one. Now folks, I'm not going to do the proof. I will not do the proof here, the 8.1. I have already shown how to do that proof in the previous video. Of course, there's plenty of videos in my channel where you can just look through full papers. I sometimes do all the proofs, sometimes I don't, because these are in any study guide. You can just download Mind the Gap study guides from the government website. You will be able to see how these proofs are done and take some very structured questions there. Those are the best, by the way. Questions from the textbooks, guys, and study guides are the best in that they build you up from just very simple, perspectives to more advanced perspectives, which are more typical of the exam question papers. Just something you didn't notice, most of the examples that are of the exam type questions are essentially past exam questions from question papers of old. So be aware of that. So don't underestimate the power of those textbooks. The intention, guys, of creating these videos is to give you a chance to see somebody navigate through some technical questions, adopt a similar approach as well, but do more yourself. You may even do these very questions I have done. You'll be surprised how you would get stuck in the process. You may have seen what I did and it looks easy, and you know what, I can follow this is nothing. Rub off the annotations and look at the question again. You'll be surprised. You will get stuck. That I can assure you. And here's what you need to do. Do that. Redo these questions. I'll attach this question paper to this memo in the description. It will be available for you to download. Download it, print it out, practice the very same question. You will be surprised when you find yourself getting stuck, because it's easy to see someone do it. Doing it is another thing on its own. So you want to get into the habit of replicating what you've seen so that you can learn independence. The intention is for you guys to attain independence in solving these questions, rather than to depend on being shown how it's done. And remember, even when you get stuck, don't rush to the memorandums. I know most of you are always, time conscious, and yet you're not learning anything. When you get stuck, leave it alone, okay? Think about it more outside trying to solve the problem. Jump, do something else, leave it alone. Don't look at the memos, don't look for solutions. Find the solutions yourself, because we can only show you so much, guys. But remember, the exam questions are going to come across. Yes, the diagram may be similar, like I showed you, but they may be asking different questions than the ones we answered. And if we did not highlight these, obviously you will have to think of it all anew and all afresh You understand? So most important thing is attain independence. Use these videos to move towards independence. That's what we want. And by the way, in the next year, I will feature most of my former students or people who are, maths fanatics like myself, who have been a part of this channel, which I thank them a lot for, because my channel is not really standing still. Yes, it's not really moving as fast as I would expect it to, but it's slowly but surely growing, and it's because of the guys who really share the videos, like the videos, and have subscribed into these videos and are preaching the good word to the rest of the other students they can come in contact with. So I'm really grateful, guys, for that. And in fact, I propose that some of you who can handle maths, just choose a question from any question paper you like, be it a whole paper or part of the paper or just a particular question. Please record yourself solving that and explaining it and email it to me. And if it is a video that WhatsApp can take, send it through on WhatsApp, and I will add that video onto the videos of this channel so that you guys can be featured, so that we can show these guys that this channel is not really sitting there just for me to drive it forward. You guys can also drive it forward. And in fact, you are going to be essentially testifying to the benefits of having been a part of this channel, or at least being a part of this channel. So let's do that, guys. Let's do that. And of course, I will try to monetize this thing. I haven't done it. I'm having problems anyway with the address things. Where I stay, the address is a bit shaky. Now I was supposed to receive, a pin to activate here. So I'm not getting that pin. So what I'm trying to say, guys, if the video that you guys are going to give it to me makes the hits, I will make sure you can see how much money that video made, and all that money can come to you, because I'll give it to you nicely. So remember, guys, your hard work is not just going to be there for me only. It's going to be there for you as well. So let's move on before I spend too much time not doing anything. Okay, so that means if we have to prove this, we're going to apply it here. But this is the main question I'm going to answer right now. The proof you can learn by yourselves. You don't even need me. But if you want to see what I have done, check my previous video, which is the November 2025, 2024 mathematics paper 2 exam. I've done that proof there for you guys to benefit. Anyway, let's get into this question. It says in the diagram alongside medians AM. Now, do you see that word medians? Now, guys, I know you know very little about triangles, which is sad, because nobody teaches you these things. I don't know if they still teach this. I mean, this word, I think we studied this in grade 10, if I'm not mistaken, because by grade 11, we were essentially applying that knowledge. All right, so medians is basically a straight line from one vertex of a triangle to the midpoint of the opposite side. So meaning this being a median, for example, CN, it means it bisects AB into AN equal to NB. That's a median. Okay, now AM is also a median, AM. So this means this part, wait, what am I doing? AM being a median, it means it will bisect that side BC of this triangle. But now, do you notice something? The medians are coming together at that point, and we call that point the centroid. We're told these medians of ABC intersect at O, and this means O is the centroid. Sometimes you would be given this story and we are told that O is the centroid. This already means all the straight lines that come from vertex across, passing through that line, those are essentially medians. So know how to interchange the meaning of the word depending on what is given. Okay, great. This is very good. And if now O is the centroid, now what story do we get? We will then appreciate that from here, we know that OC is basically 2/3 of NC. That's the idea. And of course, if we divide by NC, therefore we will have OC over NC, giving us 2/3. This is very good, guys. Please know these kinds of things. Medians always do that. This ratio is inherent. Once we know that something is a centroid, then a median is sort of like sectioned or divided into that ratio by the centroid. All right, so that is the story, guys. And then of course the same would go for AM. We know that AO is going to be 2/3. It's 2/3 of AM. And if we divide by AM, we will have AO over AM, giving us 2/3. So again, guys, this is very key. We need to know these kinds of things. But now remember, if these are medians and this is the centroid, can you see BP or BOP looks like a straight line? And if information is given that this is a straight line, this will also do the same. This will also do the same. We will have a situation where this is essentially going to do the same, because if this is the centroid and this is the straight line from the vertex to the opposite side, then it cuts the opposite side in half. It will itself automatically become a median. And O is what we call a point of concurrency, because this is when 3 or more lines intersect. We say those lines are concurrent. Anyhow, let's leave it at that, guys. Sometimes overly saying things is dangerous. But let me say something before we say a lot. Do you realize if this is a median, let's assume this is also a median. For now, we don't know if it is a straight line, but if it is, let's say it's a median. Do you see this point is the midpoint of AC? M is also the midpoint of BC. And we know from grade 10 that a line that joins midpoints of the two opposite sides in a triangle is going to be parallel to the third side. And it's not just going to be parallel, but it's also going to be half of that side. That's the midpoint theorem of triangles. So can you see, guys, from just very little given, we can deduce a lot. That is the most important thing. Anyway, let's read on. We're told BO is produced. Do you see that? BO produced. What does it suggest? Straight line. Produced to cut AC at P. Can you see? This is indeed a straight line. And if it passes through the centroid, it is the median. It will cut APC into 2 equal parts. And so we know indeed this property we just explored is there. Now we're told MP and CN intersect at D. MP and CN intersect at D. Okay, that's fine. Is there any significance to that? Well, at this stage, I don't think this means a lot. It doesn't look like. But remember, statements that are given, guys, have a tendency to have a particular meaning. But when two straight lines intersect, for me, we get vertically opposite angles and many other things to think about. So I don't think there's much to read or to learn from that. Let's leave it at that. But for me, it just proves this is a straight line rather than anything. I think this is just to suggest this is a straight line. This is already given as a straight line, we know, but we probably didn't know this. So this is the examiners trying by all means not to leave you thinking or assuming, but knowing for sure this is a straight line. Okay, good. Now OR parallel to MP. OR is parallel to MP with R on AC. Okay, that's fine. So this is good. Now we are good, guys. We know all those ratios, even AO, or we've done AO and that one. Now we can even include this BO, because it is now a median. It's going to be 2/3 of BP. We can say therefore BO over BP is going to be 2/3 as well. So that is key. Now folks, this is it. So we can now try to see, look at what we can see is going on now. So look at these two triangles. Can you see this line is drawn parallel to the third side? So we can use the proportionality theorem. Same, the shaded triangle. Can you see one side is drawn parallel to the other? In fact, we can even push it like so. Can you see that? So if we look at that, we can use the proportionality theorem in those two triangles. So this is very, 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 very important, and yet we know the ratio of AO over AM, and that would also give us AR over AP. So this is good. This is good. From just knowing a few things in a mathematical sense, then we can do a lot of damage if needs be. All right, folks, let's answer the questions before we waste too much time. Calculate with reasons the numerical value of ND over NC. ND over NC. Okay, so that's what we want. Now, how are we going to do that? Now, it looks like we need to do something. Remember, we just realized that these two, these are parallel to that from the midpoint theorem. So this already suggests we need to look at yet another triangle. Let us staple it instead. Now have a look at this stapled triangle. Do you see now proving this line right here is parallel to that line? So we've got another proportionality theorem. This ratio over that ratio should be equal to essentially that ratio over the other ratio. So that is essentially what we need to do. But now, this means before we can go that far, we will have to essentially, I'm trying to think now, we will have to essentially this is good. I mean, this is just gonna be half, isn't it? It's gonna be half because this AP is equal to PC. Of course, we need to justify why that is. This is the centroid, we can say that, intersection of the medians. So if that's the case, now this means from the midpoint theorem, this line is parallel to that. We need to come up with that. From there, we're just going to do the ratios nicely, easily. Interesting. Let's start first by uncovering these lines are parallel. So we will say here, first and foremost, we understand that essentially AP is going to be equal to PC. What's the reason? We can say O is the centroid of triangle ABC. And since we were told this is a straight line, it becomes a median. Nice and easy. This is very easy. Very easy. And likewise, we can say likewise BM is going to be equal to MC. Again, O is centroid of triangle ABC. Of course, we were given that this is a median. You can even use that and say AM is the median. So a median will cut that side into two equal parts. So it's not a problem. Now, what are we going to say? We know now when a line that joins the midpoints of the opposite sides of a triangle, it should be parallel to the third side and even equal to half of that. So we can say, therefore, we will appreciate that AMP is parallel to AB. Now what are we going to say? Midpoint theorem of triangles. Okay, because in general, we know that a line that joins two midpoints of the opposite sides of a triangle is going to be itself parallel to the third side and equal to half of that length as well. But at the moment, we're not interested in the length per se. We're interested in this parallelity because it will drive us into our stapled triangle. Right? Because in our stapled triangle, we will then answer the question. We can say then, in triangle ACN, what will we see there? Now we've got one line drawn parallel to the other, so the ratio and proportion business. So we can easily say, well, ND, which is what we want, over ND over NC is going to be equal to essentially AP over PC. Sorry, not PC, but AC. So what is that? This is the proportionality theorem. This is the prop theorem. Now we can state that DP is effectively parallel to AN in this triangle. And we know that this is part of those lines. Hence, we were told that these are straight lines from this statement. See, very important, very important. Okay. Now, what did we say, guys? We know, okay, let's just do it. We can say this implies that ND, Natal, Devon, it used to be that, right? Natal, Devon on the number plates. Of course, this is now AP over. Now, what did we say? This AC is nothing but AP plus PC. Right? We need to show that. Which also implies that ND over NC is going to be AP plus. Instead of writing PC, because we said those are equal, we're just going to say this is going to be 2 times AP. Because PC is equal to AP. We know that. In fact, sometimes we may remind the examiner that we proved AP is equal to PC, so that they can fully understand why all of a sudden we have PC. But of course, a student who likes to be systematic may also show that PC as AP before doing that. But I mean, if you can justify for it, someone will understand what just happened. And now what happens? We know that this is common, so it divides to 1. And in maths, when we divide to 1, 1 becomes invisible. So we know that, in fact, therefore, ND over NC is going to be a half. Nice and easy. So when it says numerical value, we leave it at this. Nice and easy. Can you see, guys, these 6 marks look horrible, but if you just have a way of going around your business nicely, none of this becomes a problem. So let's go for it. This is a mark, definitely. And that is important. And essentially, this is more important than the rest, right? Right, because this was already implied by this being a median. But the other one, we needed to find out what this center is. It's the centroid. So more important in my opinion. And then, of course, this statement and reason, important. And essentially, okay, maybe getting here. But I think when we substitute this, it's mark worthy, 1, 2, 3, 4, 5. Yikes. Okay, maybe let's give it, it's fine, 6. At the end of the day, we have 6 marks, no matter what. Sometimes you may say 2 marks for statement and reason here. It's quite a powerful one than that statement, than this substitution here. All right, easy stuff, guys. Let's move on without wasting too much time. 8, what was this? This was 8.2. So this is 8.2.1. Okay, good. So we've got 8.2.2. See, heavy questions. If AO over AM, can you see they're making it look like it's not the case? Of course, be very careful. We know that this is true, but the examiner can decide to choose a ratio for themselves, although it may not be representative of the diagram sometimes, but you use what is given. But this is true because this is exactly what we know. Remember, AO over AM was 2 over 3 from theory, and now they're giving it to us as if it's not the case. This is just to try and highlight that fact, so to someone who's not aware. Now we need to calculate the ratio. Again, remember numerical value, so we leave it like that. We don't simplify it like that. Remember, do not do that. We must give it like SWA of RP over PC, not a problem. So obviously, guys, this is already suggesting we need this this purple triangle. We get that ratio from the centroid, and we're going to use this ratio eventually. So this is what is going to happen. But remember, if this is 2/3, this is 1/3, right? So this is literally, if we look at it, if we look at this portion over that portion in that triangle, if we say this is 2A, this is definitely A, isn't it? So that's what we need. That's what we need. Okay, good. All right, okay, all right. Now we're going to say, essentially, in this triangle, AMP, adenosine monophosphate. You will learn things when you're doing life science, guys. Very interesting stuff. Okay, let me not relax too much. What do we see here? Now this parallelity was already volunteered. We don't have to justify for it. We just use it. We know, guys, that essentially, first of all, we know, we need to say this. We know that AO okay, now what we were given is a bit strange. It's not a problem. We are given that AO over AM is 2 over 3. Okay, great. So this is 2 I can't like Elianto. I don't like what I did here, man. And let's just get rid of it. So let's do it again. We know that this over this, that's what we were given. So we are going to say this is 2A, therefore this becomes 3A. And we know that 3 minus 2 gives us A here. So you guys, sometimes so you need to be able to see. What matters is to see. And if you annotate, make it clean. I mean, this looks heavy and horrible, but someone understands what is going on in there. Because if you annotate, you make it look nice. This is given. So from here, we can see, guys, that essentially, this is given. Even if it wasn't given, we could easily say O is the centroid. It always divides like this into this ratio. But now it's given. So what we need to conclude is to say essentially AO over OM is supposed to be now 2 over 1. Ne? Very easy. Because if that's the ratio, and we're still talking about the same line about the centroid, this is what we need to expect. Okay? I think that is key. Ne? Yeah, man, we can say again, go with then. We know that AR over RP must be equal to AO over OM. This is nothing but the prop theorem with essentially OR parallel to MP. We're still talking about that same triangle. This implies that AR over RP is going to be equal to, now what is AO? It's 2 is to 1. Okay, so we can write this, that this is going to be 2P if we like. Okay, maybe let's not use P, let's just say 2Y over Y. Here's the stuff. Now, what are we supposed to do? We just do what we need to do. We can say here, therefore, we can say PR or RP. Therefore, RP over PC is going to be equal to Now what is this? This is just y divided by, remember, we know that AP is equal to PC. So we're just going to write essentially AP instead. This is going to be 3y. I'm running out of time, guys. It's a mess. So I don't want to waste time. And then the y's to the thing. This is just a third. Easy. Not so smooth as I often like, but it works. It works. It works. It works. So what is important, guys, is to get this right. For statement and reason, we get a mark. And essentially to get this is important, and to get that is important. So this is how these 5 marks can be scored if we look at what we had to do. So we did not even need that much of this one, but we can use it if we need to. But at this point, we leave it at what we have just done. As long as we have answered the questions, we move on. Okay. All right, guys. So this is fun stuff. So these 18 marks were a bit technical. This is where the student is like, woo, asking questions. What is going on here? Well, what's going on is a mathematical exam. Okay, let's get to question 9, which is the last one. Like I said, guys, explore other options of solving the same problem, please. Explore other options. It helps a lot. Okay, let's try and finish now. We must not get to 2 hours. We must not. Let me drink some water. amnandi amanzi kaniyeke nusela idrink futhi ningasele ezo zinto nisincede nizawuguga msinya. Nanisela amanzi, guys. Amncaniwe sela amanzi. Naxa uhamba endleleni, if you're traveling, if you feel thirsty, buy water. Don't buy cold drink. Don't do it. It's not good. Anyway, in the diagram below, AD is the diameter. Okay? Now where is you? Sisi? Is it sisi okanye boti okanye tata okanye mama? Whatever. If this is a diameter, it subtends a right angle at circumference. Angle in the semicircle. That is the one. I'm antena tuna mqala kabi. Hehehe. Ayiwena man simkezela. Okay, iPhone, guys. Sometimes iyapapa lento. So that should be 90 degrees. That's the angle in the semicircle. So can we see if this is 90 and this is 90, and these, we know they are corresponding angles. So when corresponding angles are equal, it means the lines are parallel. So that is the story being propagated here. Can we see, guys, already setting up a similarity situation for the bigger triangle, or we're also setting up a similarity situation for this encircled triangle. So we can say it's a is it a circumscribed or is it an inscribed circle? But inscribed triangle in a circle, whatever, guys. Anyway, this is the story, you know. And what do we know, guys? A line from center perpendicular to chord bisects the chord. Oops. So we already know that MC is equal to AM. Ne? Yeah, man. It's like this. It's like this. It's like this. This one. And essentially, guys, if this line is parallel to this one and it's joining the midpoint of the one side, this is also suggesting that this is also a midpoint. Wabona jwal. And you know what this is meaning now. Yo, guys, I'm sorry. Yo. I lied. Nobody said Q is the center. So, yay. Kabatlakele bulaisha. Abetlwele dintho tse ngata man. Se re bolela thata byanong. Okay, all right. Okay, so all we have is just a similarity situation. Let's leave the others. They are not yet the issue. But guys, I need you to notice something. Okay, let's not go off circle ABCD. Okay, can you see that? So we can see that this is a cyclic quad because all its vertices are at circumference. Good. Now, we are told that AD is produced again to meet the tangent NCP. So this is the tangent. So there is our tangent, and this line AD is then produced to suggest this is a straight line. If it is produced, we are going to do this. We produce it right there. Okay, so good. So we have this situation right there. Interesting stuff. Is it not? It is indeed so. Okay, so guys, what can we say here? We know that the angle between the tangent and the chord is going to be equal to the angle subtended by that chord in the alternate segment. Nice. That's the 10 chord theorem. Good. Is there anything more we can say at this point? Not so much as yet. We can just leave other things. I mean, there's plenty other things. We know that that angle is also equal to that angle. Still 10 chord theorem. Or one may think of angles in the same segment subtended by chord CD or arc CD. But we can see this is the common chord for that angle and that angle. Not a problem. It's all good. So there's a lot, guys, we can say. But I think we must not say too much as yet, or we will run ourselves into a big problem. We're told here straight line NB. Where is NB? Straight line NB is produced. See? So this means NBMQ is a straight line. Okay, not a problem. AC, okay, intersects AC at M with Q on ADP. Okay, not a problem. We are told that AC is perpendicular to NQ at M, so that is indicated. So that's all. So we have what we have. Sometimes doing too much is not necessary. But remember, this parallelity, we need to justify it. We can't just assume they see it. We have to assume somebody doesn't see it. And so we show it to them, those who are interested. 9.1 says prove that NQ is parallel to CD. Can you see that? Very nice. 3 marks. So some questions can be easy. 9.1. We know that angle C2 is equal to 90 degrees. Why? This is the angle in the semicircle. Right, we were told AD is the diameter. We can say this implies that essentially C2 is equal to angle M2, each equals 90 degrees. That's the story. We can therefore make a conclusion that therefore indeed NQ is parallel to CD. We can say corresponding angles are equal. Right, because C2 and M2 are corresponding angles. And when corresponding angles are equal, therefore the lines are parallel. Well, this is a very strong statement. Right, we can then link this one and say the last mark is for the reason. Good. Okay, but of course we could get 2 marks for the statement and the reason, and then get a mark for the last reason, because this is already evident. This may not be mark worthy actually. We can get 2 marks for that first statement and 1 mark for the last reason. This is a deduction which is evident. Okay, all right. Let's get to 9.2. 9.2 says prove that this is a cyclic quadrilateral, A and CQ. A and CQ. Whoops. So this means we need to do this. We need to prove either that this angle Q1 is equal to this angle. Right? Right. Because these would be angles in the same segment subtended by arc NA for this to be a cyclic quad. Right? Right. And this is already going to work out because we know that that angle is angle between the tangent and that chord, and this chord subtends this angle at circumference. Great. And we can appreciate that this angle is definitely equal to that angle. These are corresponding angles since we proved these 2 lines are parallel. Easy stuff. Because to link this angle to that angle would be a little bit challenging, because that's another way we could prove it, but that would be very difficult to do. They are very, very far apart, but I think we can actually do it. Yeah, we still can. Remember, this is the 10 chord theorem, right? But this angle is equal to that angle. Why? We proved these lines are parallel, so these would be corresponding angles. Therefore, this angle is equal to that. So that's another way of doing it. Okay? Always explore your options, guys, while practicing. I cannot overly emphasize that, because at the end of the day, once you prove angles in the same segment are equal, then this bow tie situation says there's a cyclic quad here. So, what can we say? We will say what we want to say. I do believe, let's use what we first found out. It looks nice. Or we can use, any of them. So we can just easily say, well, we know that essentially angle A2 is equal to angle C1. This is the 10 chord theorem. Right. We can say, but we know that angle C1 is equal to angle N. These are corresponding angles with NQ parallel to CD. We can say therefore angle A2 is equal to N. We can say therefore A and CQ is a cyclic quad. This is the converse of angles in the same segment. Okay, that's it. Not a very difficult one. So this statement is proper, perhaps 2 marks for that, maybe not, 1 mark. 1 mark for this, essentially linking those two, and the last reason 4 marks. Again, it depends on the marking guidelines how to go about this business. Let's just go for it nicely. 9.3. 9.3 is divided to 9.3.1. We are then asked to prove that triangle PCD so it is this small triangle here is similar to PAC. So we're comparing the small triangle to the blue outlined triangle. This is just 3 marks. Why is it 3 marks? Because it's fairly easy. Anyway, guys, so what are we going to say? Well, we can see that this angle is already equal to that angle. So this is from the 10 chord theorem. All right? Okay, all right. Now, what else do we notice here? We already need to do something, because now I am trying to think, how will we link? How are we going to link this angle? Ooh, Yana. How do we link this angle P? Can you see it looks simple? 3 marks. But it's not as simple as it looks, because now we need to link this angle. Come on, man, it's a common angle. Goodness, crazy now. Don't know why I'm overthinking this thing. Okay, let's go for it. In triangle PCD and triangle PAC. Can you see, guys, even in higher grade questions, you do get some standard grade questions like this. And sometimes it makes you to think you're gonna get stones, and yet there's no stones there. Now we understand that angle P is common. Okay. 2, we know that angle C1 is equal to angle A2. So this is proved above. And we can then deduce the last ones, that basically D1 is equal to angle ACP in the other one. These are the remaining angles. Therefore, indeed, triangle PCD is similar to triangle PAC, the Pan-Africanist Congress. Okay, it died a miserable death common to mankind, that one. Anyway, all these parties that are just going to try their best to exist, they're not gonna go very far, guys. Let's just face it. They are not multiracial. They are not multi-tribal. It's just people who are confused, who don't want to listen but want to be listened to. I don't understand what's wrong with young people of this country. They don't want to listen to anybody. They don't want to listen to reason. They don't want to follow orders, but they want to be listened to. They want to be followed. They also want to dish out orders. I don't understand what kind of people are these. Anyway, let's leave politics alone. But as we said back in the days, that none of these new and upcoming parties are ever gonna make it. But the damage they are causing of, breaking, the majority into smaller chunks, they are going to make it easy to conquer the rest of us. And yet we don't want that. We don't need that. We just need to correct the wrongs that the majority is doing right now. And if we can do that, then we have everything we want, just the right way. But breaking up into smaller chunks, we will lose everything. And yet these fools are not going to get anywhere. But hey, let's leave it to those zombies who follow other zombies to find out when it finally hits. And sadly, they'll be crying as if they didn't see it coming. Of course, they never see anything coming after all. They'll be telling the truth. Anyway, let's go on, guys. So we're scoring 3 marks, of course, for the reason. And I don't know, guys. You know what? This one is a mark. We can bunch these two into one single mark. Because, come on, guys. Maybe not even bunch. We see that this is common. That's it. That's it. So 9.3.2. We then hence need to complete that statement. Obviously, guys, once we prove similarity, we are sorted. So we can easily say PC. But now we are told to complete that statement. PC squared is equal to, now remember PC in the other triangle is opposite this big angle, right? And this big angle is equal to that big angle in the bigger one, and the side opposite it is AP. So this is going to be AP times. Now we need to look for another one. So what are we going to say? We can say dp. This would have been dp. This is going to be over. Now dp is essentially opposite that angle, and the side opposite that angle is, the angle, dp is opposite that angle. This angle is equal to that. The side opposite that is cp. Okay, I don't know why I'm doing this. I'm being crazy now, guys. Let me show you this. This would have been PC over, what did we say? PC is opposite that in the smaller. That angle is equal to that angle in the bigger, and the side opposite that is AP. This would be equal to dp over, dp is opposite that is equal to that, the side opposite that is cp. When we cross multiply, we get PC squared is equal to AP times dp. Okay, so we just write PC squared equals AD times dp. Now, remember, we were told to just complete the statement. The question is that all? No. Remember, for every statement we write, we must have a reason. So, of course, we can just say triangle PCD is similar to triangle PAC. Because we got it from there, and that's why we know those sides are going to be proportional. But this time we're being challenged into just writing this. Now, there is yet another theorem, guys. that you guys need to know. Okay, there's a theorem that you need to know. Even if you didn't prove any similarity, if we've got this situation where a tangent and there's a circle like that at C, there's a theorem that says the square on the tangent is going to be equal to the product of the segments of the secant. Ne? So even if you don't prove similarity, so there's a shorthand theorem. Okay, it's not really a theorem per se, but this is what we accept as a theorem. So we just say a secant and a tangent, if they are drawn at a particular point, from a same point, sorry, I'm saying a secant and a tangent are drawn from a common point outside the circle. Therefore, it means the square on the tangent is going to be equal to the product of the segments, which is this dp over the whole ap, the segments of that tangent. So the one reason one can give here, instead of writing what I just wrote here, one can just write, it's acceptable to say tangent and secant. So this was acceptable. I don't know if it is still acceptable in your curriculum. So remember this, sometimes when you are supposed to find this and you're seeing 2 marks, you know you don't need to do the similarity first and do this. But when you see this, but you see 4 marks, maybe 5 marks, then you need to show us this, because none of this is going to be equal to 5 marks. The moment you do this, you just get the 2 marks, because the 1 mark is for this, and then the other mark is for the reason. Okay, but like I said, you can still use the reason that triangle PCD is similar to triangle PAC. But look at the question, look at the marks. If you are told to prove this is the case and this is 2 marks, it means there's no need for that. Even if you do it, you're not going to get extra marks. You will just get the marks here. But you can do it that way, because remember, you want to score your marks. If you can justify how you scored your marks, that's good. But if you know the shorthand, techniques to this, so just write tangent secant, because when the tangent to the circle is drawn from the common point with the secant of the circle, then we know that the square on the tangent is going to be equal to the product of the segments of that secant, which is exactly what we see here. Nice and easy. 9.4. We have a situation that we need to prove that BC squared, where is it? BC squared is equal to CD times NB. Can you see 7 marks? Now that is not something you can just use a particular property and that's it. So this is already suggesting we need to prove similarity yet again, where BC is the common angle, because once this is squared, it means this must be a common side. Common side of 2 similar triangles, at least. Or we may have to maybe use some Pythagoras or whatever to get here, but this is the suggestion. Now we look at BC. BC is in this triangle, right? In that triangle. But now what do we see? We can see there that we have NB. So NB is on this triangle right here. So we can just easily show it this way. So we can clearly see it's this triangle and this triangle. So guys, we are comparing this triangle over here and that triangle, because they've got this common side BC. Very, very, very important. So how do we link these two triangles? We know that essentially this angle C4 is going to be equal to this angle D2, right? This is the tan chord theorem. Okay, good. So this is nice, this is easy. But we already proved that this angle B2 is equal to that angle. These were angles in the same segment, but we have already proved above also that A2 is equal to essentially N, and that gave us that piece of information that there was a cyclic quad there. So this already proves for us that indeed these two triangles are similar. So that's all we need to do. Maybe let's just do this question in a new page. So, okay, let's move quick, guys. So we know that we're going to be comparing triangle BCD and triangle BCN. I really don't pay attention to how I name them, because I'll always find the proportional sides by using the angles. Now, what do we know, guys? BCD, we've got D2. We said it's going to be equal to C4. This is the tan chord theorem. Okay, nice and easy. Now, number 2, we know that essentially B2 is equal to angle A2, right? What is that? These are angles in the same segment, okay, because they're subtended by chord CD, right? Right, we can say, however, we understand that A2 is equal to N. This was proved above. So it's nice when you choose things that you can use, because you see, using this technique of proving here that A2 is N was better than trying these other things, because then they don't link to any of the questions. Again, you have to skim these questions to some extent as well to know what best approach would be in answering the previous questions, so that it's easier to go through the next ones. But sometimes don't pay too much attention to that. What we want to do is to conclude that angle D2 is equal to angle B2. Why did I use D2? No, man. That's not what we want. What we want is to prove that angle B2 is equal to angle N. Each is equal to essentially angle A2. Not a problem. Now, once we prove two sets, we know, guys, the remaining set is going to be as we want it. So we can say, therefore, sorry, maybe let's not say this. Now, therefore, maybe we need a third one. So let's say this also implies that angle BCD is equal to angle CBN. But in that case, it's just B1. So let's just not complicate it. It's just B1. These are the remaining. These are the remaining. Remaining angles. Therefore, triangle BCD is similar to triangle BCN. And the reason is AAA. Okay? Equiangular. Just a moment, guys. Alright, so now we need to use the sides. So if this is the case, we know also, therefore, that BC over, now BC is opposite that angle, which is D2, but we proved D2 is equal to C4, and the side opposite C4 is NB, or it's BN. I think it's written as NB. This is going to be equal to, now we want CD. CD is here, over. Now CD is opposite B2. We just proved B2 is equal to N, and the side opposite N is BC. Okay, so this is it. I mean, this is a deduction from similar triangles. But again, I often make a reason here, even though it's not necessary. This is the proportional sides of similar triangles. Obviously, this reason is not really necessary, because if we prove similarity, this is a deduction without needing a reason. So I could easily say the reason is somewhat optional, because if we've gone through this already, we don't need to justify this. All we do now is just cross multiplication. So therefore BC squared is going to be basically CD times NB, as is proposed. Nice and easy. So so this is good. Okay, this is good. So this is good to link those. And I mean, we can just throw marks in here. So 1, 2, 3, 4, 5. You know, we can say 6 and 7. Statement and reason. Or we can give statement and reason up there and just give 1 mark here. It doesn't really matter. The marking guidelines are going to be the ultimate, but remember, you get marks. If everything is correct, you get full marks. Doesn't matter how the marking guidelines look. But if you get the wrong answer or you don't complete, then we start using the marking guidelines to pinpoint exactly where do you score some marks. Okay. Alright guys, so we're almost at the end. Let's just do the last one here. So 9.5. Now we need to prove this thing. It is further given that PC is equal to MC. Okay. PC is equal to MC. Alright, okay, alright. Now we need to prove this thing. Yeah. Ingathi sizoyibona ingxaki ingathi sizoyibona. But now let's have a look, guys. This is 1 minus a square on something. Ne? This is 1 minus a square on something. Now this is giving me the once we see a sign. So I'm thinking of Pythagoras. So where do we apply Mr. Pythagoras theorem? That theorem of Pythagoras. You see, the theorem of Pythagoras applies in this triangle BCM. Can you see? Because if this is 90 degrees, we will appreciate that this will also be 90 degrees. These are vertically opposite angles. Okay? So that is 90 degrees. And what do we see? We see a square on BM. And this is the side of this triangle. We can stipple it, by the way. Okay, there we go. So can you see the stippled triangle? BM is a side to it. And we've got BC squared. This is the hypotenuse side. And it looks like BC came from there. We just divided throughout by it, you know? Yeah, so BC is the hypotenuse. Then we've got MC, right? Now we've got MC squared. But then we can substitute MC, right, with PC, because that's what we want. Nice. So we're going to say in triangle BCM, we need to state that M4 is 90 degrees. Why? Or let's not say this, it's dangerous. Is equal to M2, and so equal to 90 degrees. Now this is vertically opposite angles. The size itself is not really much, but we need to connect the size to an angle. So refrain from just writing M4 is equal to 90 degrees vertical opposite. Where did you get this 90 degrees? Are you taking it from your head? No, even though this is 90, but we need to state that that was angle M2. These two are related. Therefore, the size of the other will affect the size of the other. So don't be careless. Don't be careless. Okay, now that we have proved this is a right angled triangle, we can say then, what are we going to say? We know that BC squared, which is the hypotenuse side, is equal to essentially BM squared plus CM squared. This is the theorem of Pythagoras. Since this is a right angled triangle, remember this is important to state. Without stating it, you're not saying anything, okay? But now we can see that this is subtracted, so we transpose. So this means BC squared minus BM squared is going to be CM squared. This is what this is. Ne. Yeah, man. It's like this one. It's like this one. Okay, I see kubanga silibele kupapa. Siyapapa sometimes, you know. Alright guys, so now we can say this also implies that BC squared minus BM squared is equal to, instead of CM, remember I told CM is equal to PC. So this is the same as PC squared. We can justify that given PC is equal to MC or whatever. Now, simultaneous equations, guys, that's all. Now what do? You can see there's a 1 there. We divide it by BC. So if we divide by BC squared, what do we get? We get BC squared divided by BC squared minus BM squared divided by BM squared is going to be equal to PC squared divided by BM. Oh, no. What are you doing? Divided by BC squared. Okay, great. So what do we know? This happens. So this implies that 1 minus BM squared over BC squared is equal to. Now what is PC squared? We proved above that PC squared is AD times DP. So this is AD times DP, ne? Yeah. AP times DP. That was PC squared divided by BC squared, which has proved is CD times NB. So this is CD times NB. and that's it. That's it. So can you see higher order questions, guys? Simultaneous equations, a little bit of, pre-knowledge, algebra, dividing and BODMAS and what. And of course, substituting certain things from above. Okay, so this is it, guys. Can you see it's not really a big deal? Not a big deal at all. So what are we going to say? We get a mark for this, and we get a mark for setting Pythagoras, right? Right. And then, so, I don't know, substituting there, maybe a mark, and then maybe these substitutions. One for PC and one for BC. Right. I don't know, guys. These 5 marks can be given however you see it. It's usually not a big deal, to be honest. If everything follows on nicely to the answer, that's it. If it doesn't, thank you very much and goodbye. Okay, guys, so that would be the 24 marks of a question of this nature. So I'm sure, guys, you enjoyed the analysis and the approach is being shown to you. So like I said, guys, I'm going to attach this question paper to this short memorandum because I'm going to break this question paper into 3 separate sections. Euclidean geometry, we'll do trigonometry, and do analytical geometry. This is just to give you a little bit more. So do your best, guys, to practice these. You may even practice these ahead of the videos so that you can use the videos to double check in case you didn't follow something, or at least to see how best you could have done something, because you will start to see that a crude way of doing things is sometimes lengthy and time consuming and very exhausting in nature. Then you start to see some very nice and precise techniques I will show you. And then from there, you refine how you do these things and you get better at them. I hope it's all good. Otherwise, goodbye. Until next time. Sizohlangana khona phambili. Phambili. Forward ever. Backward never. Yayiva lonto. Amandla. Gawethu. Okay, guys. Manje nishiye kanjalo sohlangana kwexesha elizayo. Sisebenze. I do hope you will do the right thing. Practice. Don't just watch. You're not going to learn. Anyway, guys, I will say goodbye again. I don't know for how many times have I been saying it, but goodbye and goodbye and goodbye. Until next time. Sharp. Oh, before I wave my goodbyes, you see now I'm too much in a hurry. Look, we had an information sheet, and from there, you see you would write your examination number and stuff on this page, because this would be the page, or should we say, a bunch of pages. Can you see all the diagrams given that you need to annotate and submit along are here? You see here you would be drawing the trig graph, most likely. All of these things you submit alongside your answer book or your answer sheet. So we had a diagram of these, a page, or should we say a smaller booklet containing these diagrams. These are all diagrams in the question paper that you can use to annotate, so that as someone marks these sections of your question paper, they're looking at your annotations to follow. This was the best way, not this nonsense you guys are given. This is an absolute nonsense what you guys are given. A very narrow space to write on, and there's diagrams also taking up part of that space. It's just wrong, guys. It's just wrong. So this needs to be reinstated for me, because I don't see the sense in combining everything in one small space, because really it's ridiculous. Totally ridiculous. Anyway, guys, Bye-bye.